Hello everyone. Today our topic is multi-label document classification with relevance feedback for a very specific retrieval. In this project, we explore how documents can be classified into multiple categories at once and how user input helps improve retrieval accuracy. Introduction. This slide explains the core ideas. A single document may belong to multiple categories. That is what multi-label classification explains. Relevance feedback means system improves search engines based on what user makes relevant or irrelevant. Problem statement. Traditional search engines have limitations. How do we retrieve documents match user intent more precise? Solution. Here the major challenge is how do we retrieve documents that match user intent more precisely? Why multi-label? Why multi label standard single label is not enough because multi-label classification allows every document to carry multiple tags, improving how we understand its content. Why relevance feedback? User helps refine the search. They label some retrieved documents as relevant or not. This means iterative process improves ranking quality. Workflow of the meta label document classification. First, document preprocessing, future extraction. This means TF-IDF, multi-label classification, initial retrieval, user relevance feedback, model update, and refined retrieval. Future extraction. Future extraction. Future extraction. We convert raw text into numbers. This means numerical futures helps ML model understand text. Here, TF tells us how a term appears in a document. IDF decreases weight of very common words. Relevance feedback. Relevance feedback improves query performance. Users label documents as relevant or non-relevant. Here we update the query using the original formula. This means after feedback, the search engine focus more on what the user wants. In the next slide, numerical example. Here the query is economic impact of pandemic. Here initial results include health, economy topics. User marks economics talk as relevant. System shifts query direction toward economy and retrieves more related data documents next time. Applications of search engines, legal document analysis, healthcare text classification, new tagging, academic retrieval. Advantages: more accurate retrieval, captures multi-topic documents, uses feedback to refine results, improves both recall and precision. Conclusion: multi-label classification supports multi-topic assignment. Relevance feedback refines retrieval based on user needs. Hybrid improves contextual accuracy and search performance. Now getting into coding part, here is the sample code. First, we import the libraries. Next, these libraries handle TF-IDF text conversion, multi-label encoding, logistic regression classifier, cosine similarity, sparse matrix handling. Here is a sample dataset. Each document may belong to multiple labels, multiple label classification. Here, TF-IDF vectorization converts documents TF-IDF vectors so machine learning can interpret text numerically and multi-level encoding. converts category lists into binary matrix format of classified training and lastly train classifier use finally multi-labeled class for trained retrieval function here converts user query to TF-IDF, computes cosine similarity with all documents, retrieves top k most similar results where it is the initial retrieval. Lucino relevance feedback uses moves query vector forward relevance talks, moves away from irrelevant talks, returns update query vector, apply feedback, simulates user marking doc 0 on relevant, doc 2 as irrelevant. Finally, initial retrieval means top three documents retrieved from original query after relevance feedback, better, more relevant results after adjusting query. Key takeaways are multi-label classification allows multi-topical topics per document. TF-IDF converts text to numerical values. Cosine similarity enables document ranking. Retrieval improves over time. Here is the final output of the code.